In this video, we're going to review factors, prime numbers versus composite numbers, and prime factorization. First of all, what are factors? Factors happens in algebraic expressions as well as numerical expressions. All that means is that there can be numbers, they can be variables as well. And it's the quantities being multiplied, meaning something multiplied by something equals a product, right? So this is called a factor, and this something is called a factor. So these two quantities are called factors, and then this is called a product. So a product equals factor times factor. I'll give you an example. 4 times 6 equals 24. That's a factor, that's a factor. And this is a product, right? So these are factors right here. I'm not doing a great job with my arrows here. There we go. That looks a little bit better. 4 is a factor, 6 is a factor. 2 times 7 equals 14. 14 is called a product, but here's a factor, here's a factor. 2 and 7 are factors. So keep that in mind, that factors often come in pairs or multiples. Actually, not often. Factors always come in pairs or in multiples. It's never just one number when you talk about a factor or one term. Now, what's the difference between a prime number as well as a composite number? I want you to write this down. A prime number is a whole number. Remember whole number? Oops, whole number. Whole number is natural number plus 0. 0 included. Greater than 1. Whose only factors are 1 and itself. So in other words, I have a number or a term that only one or a number rather, I have a number, only one number itself is a factor to the number. There's no other factors. So here are some examples, excuse me. Whoops. Change the color. 3, it's 1 and 3 only. 1 times 3, you can find another factor. 7, 1 times 7. 11, 7, 11, 1 times 11. So those are prime factors. Composites are a lot of, all the even numbers are composites because you have 2 out there already. 2 times 2, 2 times 3. I can have 10, 2 times 5, right? Now, what is prime factorization? Prime factorization is expressing a composite number, as a product of its prime factors. So let me explain that. It just means that to rewrite any of the composite numbers, remember composite numbers have several prime numbers hidden in them, rewriting them with those prime numbers with multiplications. So I'll give you an example here. If I have 63, I have 63 is 7 times 9. Now that's called factorization, but not prime factorization because 9 can be refactored into 3 times 3. So I have to rewrite this as 7 times 3 times 3 again. Very often, this is what you will see me doing. I factor a number into a pair, and then if any of these two numbers is not a prime, I factor that again. And then I pick up all the numbers at the end of the tree branch. This is called a factor tree, right? This is a factor tree. So all the numbers at the tree branch becomes my prime factors to the original number. So I'll give you another example. Let's try another one. Let's try 100. So if I do 100 on this side, the easiest way to do it is 100 equals 10 times 10. Both of them are factors, but not prime numbers. But 10 is 2 times 5, and the second 10 is also 2 times 5. So now all I need to do is to pick up these numbers at the end of the tree branch. The numbers above the tree branch, don't touch them. That's all there is. Okay, if you feel like you're so advanced, you see 2 times 2, that's 2 squared. 5 times 5 is 5 squared. You can rewrite that into 2 squared times 5 squared as well. That's perfectly fine. I will take either one as a correct answer, as long as you give me the prime numbers as factors. So there's some practices below. There are different ways to factor each number, and 3 ways actually in the first row. So finish those exercise and we'll discuss it in class, or check your key on the online in PowerSchool Learning. All right, guys, thanks. Bye.